Hi, I'm Mr. Peck here. Now we enter the second questions in centripetal force. Let us do the question together. The diagram shows two of the forces acting on an aircraft which is moving in a horizontal circle at a constant speed. L is the lift force and W is the weight of the aircraft. Okay, so we have two forces acting on the aircraft, the lift and the weight. Calculate angle theta. So theta, this is the theta. If the speed of the aircraft is 105 meter per second and the radius of the circle is 1,500 meter. Oh, so he already give us the speed. Sorry. Give us the speed. Yeah, the speed and also the radius. And another thing is assume the acceleration of the free fall is 10. So this is the G. The G value cannot use 9.81. You must use 10. So be careful. They ask us to find the theta. So information is this lah. Okay. So these are the information: V, R, radius, and G value. Okay. So when we do the chapter 6 question, remember do like the chapter 4 forces. Draw the free body diagram first. Draw the free body diagram. Show all the forces acting on that point mass, and also show the direction of acceleration. In this case, we use centripetal acceleration, AC. Okay, so now this is the diagram. This is the wing, the airplane wing, airplane wing. And this is a circle he tried to make. So you see, when it's tilted to the left, means you want to turn to the left. If the aircraft tilt to the left, you want to turn to the left. When the aircraft tilt to the right, you want to turn right. Yeah, you can see, yeah, like the aircraft may tilt to the left, you want to turn left. May tilt to the right, you want to turn right. That's all. Yeah, why he want to tilt? Why the aircraft want to tilt? Because the x component of the lifting force provides the necessary centripetal force for the aircraft to turn in the circular motion. Because you must have the x component velocity, x component force. If no x component of lifting force, then it cannot make the circular motion. Understand? Okay, let us check where is the resultant force. In this case, the resultant force will become the centripetal force. Right? So, okay, this is the wing, and this is the angle theta mixed with the horizontal. Okay, this is the circle he makes, and this is the center of the circle. The lifting force is perpendicular to the wing, and the weight is directly downward. All right, and then because the center is at the left-hand side, so the centripetal accelerations is to the left. Okay, it's to the left. Theta degree is the, this is the wing. As I said just now, this is the wing. This is the wing. So theta is the angle between the horizontal and the wing. This is the theta. All right, the theta. Now, before we proceed, we see the weight is already in the y component. Okay, but the L is not at any component. So you must resolve the L first. We must resolve the lifting force. So how to resolve? Okay, so you see L has the x component and also the y component. So what is the x component? We need angle. So first of all, we don't know this angle. We put as maybe we can we put that as sorry. Right. Okay. So this is the alpha. I'll put it as alpha. You see, this is actually 90 degree. As you can see here is 90 degree. Between the lifting force and the wing, it is 90 degree. So we can say theta is actually theta is actually 90 degree is actually the theta plus alpha. Okay, theta plus alpha. Okay, so we need the alpha because we want to resolve the component of, we want to resolve the L into components. So what do we have? We have okay, adjacent to alpha is L cos alpha, and opposite to alpha is L sine alpha. Okay, and then don't forget to put the positive and negative sign. Follow acceleration is positive, opposite acceleration is negative. Okay, follow acceleration is positive. Now look at the x component. X component, we have centripetal acceleration. So S component use MA because got resultant force. The resultant force is the centripetal force. Yeah, is equal to MAC. Now, what force we have in X component? We only has one, L cos alpha. That's why the airplane needs to tilt. It needs to tilt, then only the lifting force also will tilt to provide the L cos alpha. This L cos alpha becomes the centripetal force. Understand? This force, L cos alpha, it becomes the very much needed centripetal force for the circular motion to happen. You must have L cos alpha, then only it can make the circular motion, then only the aircraft can turn. So just write that down. So L cos alpha is positive. Positive because it's same direction with the centripetal acceleration. Just write that down, yeah? Just write that down. So we have L cos alpha equal to MAC. AC formula is V squared over R. So we have mv squared over R. Okay? That's great. We have the formula. Now, y component also we must do. Y component, it has no acceleration, so it's equilibrium for y component. So Fy equal to 0. We can just use L sine alpha minus weight. L sine alpha minus the weight equal to 0. So L sine alpha equal to mg. Okay? So now we have two formula. We have formula 1 and formula 2. Okay, so now what we do, we can divide them. Just sine divided by cos. So 2 divided by 1 because we want to use sine divided by cos. So L sine alpha divided by L cos alpha equal to mg divided by mv squared over R. Okay? So you can cut off the mass and continue. The R go above. So here we have Rg over V squared. Okay? Rg over V squared. So that one, L can be cut by L. Sine divided by cos, we get what? Sine divided by cos, we get tangent. Tangent alpha equal to Rg over V squared. Now, just substitute the value of Rg and V. Our R is 1500. G is 10. Okay, substitute. 1500. G is not 9.1 is 10. Okay, divide by the V is 105. 105. Alright, so find our alpha, antitangent. So after that, antitangent, we got the answer for alpha is 53.68 degree. That's right. So we got the alpha, but what we need is the theta, not the alpha. We need the theta. So to find the theta, just now I say 90 degree is theta plus alpha. So how? So we got alpha just now. We got alpha just now 53.68. 53.68, just put inside. So 90 equal to theta plus 53.68. So our theta will get minus out 90 minus 53.68. We got 36.32. Oh, sorry, 32 degree. That's the theta. That's the answer. Okay. Now, discuss the effect of the motion of the aircraft by increasing the theta, assuming the speed remains constant. Okay, now what happens if I increase the theta with speed constant? What happened to the motion? This one, you need to use equations to prove. Use equations. Increasing the theta, V constant. V constant, increasing the theta. So what formula have the theta? Let's find out. What formula have theta? We have, first of all, we have this one. 90 equal to theta. Okay, we can say this is theta actually is 90 minus, we can say it this way. Alpha actually is 90 minus theta, isn't it? Alpha is 30 minus theta. So let's write that down. Alpha is actually 90 minus theta. Okay, so when the theta goes up, you say increasing the theta, isn't it? So when theta goes up, minus, so alpha goes down. So which equation has the alpha? Which equation has the alpha? Okay, we have this one. Tangent alpha equal to r squared over g. Rg over v squared. So let's write that down. We have the tangent alpha equal to what again? Sorry, what again? Rg over v squared. Rg over v squared. Okay, so if the alpha goes down, what he asked is, okay, he said V constant, isn't it? V constant, okay, V is constant. So G also constant. The only thing can goes down with alpha is the R. The R. So the R also will go down. Okay? So R goes down. So R goes down means what? Means now the aircraft turn in a smaller circle. The aircraft turn in a smaller circle, or circle with a smaller radius. It means it turn faster. Yeah, it make a smaller circle already. Yeah, it can turn sharply. Can turn in a smaller circle. Yeah, that means when theta increase, it tilt more. When theta increase means, what it means by theta increase? Theta increase means he tilts more. Yeah, maybe the aircraft now becomes, instead of just 30 degree, now it increased to this way. Wow, it's turning more. Turning more. The lifting force is much steeper. This is the aircraft. Now he's making almost, almost 60 degree instead of 30. Tilt more. So he can turn faster, can turn faster. Turn in a smaller circle, smaller radius. So let's make it that bigger. Let's make that bigger. Okay. In a smaller radius. Turn in a smaller circle. Okay, good. Now, when the radius smaller means smaller circle. Okay, what if he turns at 90 degree? What if the angle of tilt now become This is the angle theta. Why did angle theta become 90 degree? If theta become 90 degree, then there's no more lifting force. No more lifting force, the outward vertical component of the lift force vanishes, gone. So the aircraft will fall. The aircraft will move downwards, will fall, because no more lifting force. No more lifting force. Right? No more L sine alpha. Because why? L sine alpha is important to hold the aircraft, to hold the weight of the aircraft. If no more L sine alpha, you cannot hold the weight of the aircraft, and the aircraft will fall downwards, at 90 degree. This is the theta. Okay, I hope you enjoyed the lesson. Let's continue to the third questions.